Hi, welcome to part 15 of the video series about work and energy. In the previous video, we learned about power, which was the last part of the chapter of work and energy. In this and the following video, we are going to solve two more questions to understand the topic better. A 5 kg block is released from rest from a height of 5 meters and slides down a frictionless incline to point P, as shown in the diagram below. It then moves along a frictionless horizontal portion PQ and finally moves up a second rough inclined plane. It comes to a stop at point R, which is 3 meters above the horizontal. The frictional force, which is a non-conservative force between the surface and the block, is 18 newtons. Calculate the angle theta of the slope QR. Let's move to a new page to have some space for the solution and redraw the diagram. As we already seen in the previous topics, to calculate an angle, we generally use inverse of a trigonometric functions like sine, cosine, or tangent. To be able to do it, we need minimum two sides to be known. We already know the height of incline QR. It is 3 meters. The other side which we can calculate is the length of the incline. In other words, displacement of the block between the points Q and R. This length can be calculated by using one of energy principles. We are going to use the formula for the work done by non-conservative forces. Work done by non-conservative forces is equal to the sum of change in kinetic and potential energies of an object. The reason we are using this formula is that there is only one non-conservative force in this question, which is the friction force. And what is more important, this force is only doing work on section QR, for which we have to calculate the angle of incline. Work done by friction force is equal to friction force times displacement times cosine theta. Kinetic energy is equal to 1/2 times mass times square of the velocity of an object. Finally, potential energy can be calculated by multiplying the mass of an object by gravitational acceleration and the height of the object from the reference level, which in this case is the ground level. Friction force is 18 newtons. We don't know displacement yet. Angle between the friction force and the displacement is 180 degrees as they act in opposite directions. The block is released from rest and comes to stop at the end. So initial and final kinetic energies of the block are 0. Mass of the block is 5 kgs and gravitational acceleration is 9.8 meters per second square. The final height of the object at point R is 3 meters. The initial height of the point it is released is 5 meters. Length of the incline between points Q and R is 5.4 meters. Now that we know two sides of a right triangle, we can calculate the angle of incline. The sides we know are the opposite side to the angle, which is the height of 3 meters, and the hypotenuse, which is the length of the incline, 5.4 meters. Opposite side over hypotenuse gives us the sine of an angle. So inverse sine of this expression will be equal to the angle. Theta is equal to 33.44 degrees. In this video, we solved an example by using the formula of work done by non-conservative forces. In the next video, we are going to solve an example by using the work energy theorem. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.